Cool. There we go. Okay, we're recording now. In addition, and I was going to tell you guys on this slide that everything here is going to be wrapped up in kind of just a quick information, and I'm going to send it out onto the Slack channel, just with everything kind of going over here about class. So we are on lecture slides. Again, I want to give you as many resources as possible to complete Unit 2 with as much confidence as possible. So lecture slides, like the ones we're going over today, will be available. I'm going to have those available on Google Drive at that link below. Again, I'm going to type that message out in Slack, so don't feel like you have to copy this gigantic link down on a piece of paper right now. Don't worry about it. I'll send it out later. The next thing, and one you've already seen before, is the exercise videos. In addition, I'm going to be providing the lecture videos as well as the studio videos. So those exercise videos are going to be a bit more casual, if you couldn't tell by some of the editing there. I do talk a little fast in those just to keep it down to a typical pace. If I do talk too fast or apart and you really don't understand it, just feel free to reach out to me. I do want to keep my time as available for you all as possible. So exercise videos will be released the day before lecture. The next one is studio videos. This is just reviewing those studios that are at the end of every class or a majority of classes. I go through that one in much more in depth to solidify some information. Those will be available at the very end of class. So at 8:30 tonight on my YouTube channel, should the first studio video will be released. Again, all these can be accessed at that link below, but it'll be sent out later. And then finally, those lecture videos will also be available. So 3 big pieces: lecture information, the exercise videos, and the studio videos, just to go over what we've talked about here. And then one-on-one meeting time. Again, I want to keep my time as available to you all as possible. So to do this, I want to open up my time on an app called Calendarly, which I still can't pronounce the name right, but it's really just a website you can go to book time with me. If you have a question, a comment, or you just need to talk, I have time available out for everyone to go to this link and just post time with me. If I am available, the time will show up, so feel free to book that. Now I'll leave it open to any general questions, not about Unit 2, but just about how class will work, anything I left out, anything at all. Okay, if anything comes to mind, again, feel free to message me. This also leads, I'm going to use this slide again because I love to recycle. If you have questions in class, again, please, please, please ask those questions. I don't want to leave any question unanswered. That question you have, most likely someone else in this class will. Statistically speaking, we have over 100 people in this class. Someone else will have your question. Never think it's dumb. Never think we've already gone over it. I love to answer them. I'm happy to continue to iterate, because at the very least, we need to go over it one more time, just so it's ingrained in everyone's memory. So please ask those questions. Again, if you do not feel comfortable, feel free to directly message me. How is the round robin work? Jay, could you expand a little bit more on that?
Just, I've seen that it's posted, and there was an explanation in there, and it didn't make a lot of sense to me. Yeah, I don't remember who even posted it.
That would have been me,
okay.
Sandy. Hi,
yeah.
Jay. We know we know each other. I just wanted to know, that's not actually something that one of the TAs or Greg or anybody set up. That's just a bunch of us who worked together over the break and realized that it was really helpful just having students also as resources. And, you know, if you need somebody to look at your code and say, hi, and just like listen to you and, yeah, just help out where we can. That's all that is.
Okay, is that just like an open Zoom meeting, or?
Anytime you want to hop on, if you have time and are just looking for somebody, if you don't have a TA available or whatever, or you just want to do review with somebody, because sometimes it helps to have somebody else to like bounce things off of or like go through things with you, because it helped me, so I figured it'd help everybody else.
Okay, so you just basically log in there and
yeah,
see if there's anybody there.
Yeah,
right?
just post right in.
Okay.
Right? No, it's not a formal thing. It really is just us trying to be helpful and help each other. So
cool. Awesome. Yeah, if anybody else wants to know about round robin work, feel free to reach out to Sandy, it sounds like. So awesome. It's always great to work with each other too. That's definitely going to help. So, any other questions anyone has? Danny, I see your question, and I'm happy to get to that. I absolutely will. So, okay, yeah, for sure. I will definitely get to these questions. I want to get through one more section before we start talking about code, even though that is my favorite topic. We got to get through one more thing, and I swear we can start talking about Java and JavaScript. All right. Again, welcome to Unit 2. This is where we begin. We're going to start getting into that realm of Java. So just like Unit 1, there's going to be expectations of Unit 2. This is assignments. In Unit 2, you're going to have 4 graded assignments. So luckily with these 4 graded assignments, there's not going to be any dead-on drop assignments. Instead, everything's going to be expected to be done at the very end. But again, that doesn't give us really the invite to fall behind. We don't want to do that. So make sure those assignments are always turned on time. But just want to let you guys know that. In addition to these 4 graded assignments, we also have Studio 19. In this unit, Studio 19 will be turned in to your TA and graded. So just keeping that in mind. As we get closer, of course, we'll do some reminders, but I just want to let everyone know that now. And select this one. Java will obviously be the primary language of this unit, but we'll also be dealing with other technologies as well, which we'll discover as we're moving forward. And then the biggest thing is that don't forget, Unit 1 is not going anywhere. Those concepts that we learned are definitely going to help us in Unit 2. So don't forget anything. If you have those notes or something, feel free to look back at them, review, but those concepts will definitely help us as we move into Unit 2. All right, any questions about Unit 2? Oh, okay, well, again, any questions? Keep slacking me. All right, so on to Introduction to Java and Data Types. So we are going to be talking about Java and some of its data types today, as well as getting a little bit into IntelliJ. So before I dive into that, just going back over to Danny's question, do you think that Java will be easier to understand or JavaScript? So if anyone else has this idea before we start hopping into this, just know Java and JavaScript are very similar and those concepts are very similar. Once we know one language, it's like riding a bike. We just have to go onto a different kind of bike. We use the basic concepts that we learned in JavaScript and we are going to be bringing them over into Java. So it's not a matter of fact of which language is easier to learn. It's the fact that you all already learned a language. And the fact that you learned a language helps you immediately into Unit 2 because all we have to do is apply what we learned, those basic concepts, into Java to help us progress in this language. So essentially, you already know how to ride the bike. We're just hopping you onto a different bike. We're going to go from there. Of course, they're not going to be sometimes they're not going to be exactly similar, but when we move forward, you guys will see what I'm talking about, hopefully. So did I do all the downloads for Java? Can you give an explanation of how IntelliJ works with the JDK? Yeah, absolutely. When we hop into IntelliJ, I will be happy to do more emphasis on how the JDK kind of runs in IntelliJ. Let me just go to that. Over here. Cool. So let's get started. On to Java. Who or what is Java and what does it want? What in the heck is Java? Why couldn't we have just stuck with JavaScript? Why do we have to learn a new language? What's going on? Why can't I just graduate right now? It's because we're going to be getting into a new realm of language that has different characteristics to it, which brings different pros as well as different cons. A lot of different people out there in the world today that are in the technical background or technical industry know multiple languages because different languages are better for different tasks. That's why it's good as us as up-and-coming developers to learn a new language. But before we start diving into a brand new language and going off into the deep end, we're going to take a step back and we're going to just remember our old friend JavaScript. Now, who can tell me how to declare a variable? What word do we start with?
Let. What?
Very good. Then what comes after let?
Variable name. Yeah.
Very good. Variable name. Awesome. And then say we wanted to declare a string. What do we do?
Quotes.
The
Quotes.
operator.
Awesome. Very good, guys. So let my variable, which is just going to be the example name of my variable, equal dog. That's how we declare a variable in JavaScript. How do we declare a function?
Function name.
Function name. Awesome. And then we have those curly brackets. In this one, I'm not going to have that function keyword, but we're just going to put that there. So the final thing is, because I don't have that function keyword there, what that indicates is that we're within a class. So I'm going to wrap this in a class here. This is our typical JavaScript example. We have our variable at the top, we have our function, and then it's wrapped in a class. Any questions on this? Everyone remember this 2020 stuff?
Yeah.
All right. So let's just make sure. I'm going to declare an instance of my class. And then I'm going to say my class.myFunction and pass in the string cat. Who can tell me what the output's going to be?
Equals new cat. My. Is there an output? I don't see where you use it anywhere, unless it's just console log and cat.
Sorry, yeah, so output would be synonymous for console log. So output, console log, what would be outputted to my console?
Cat.
My parent is cat.
Very good. And what would be the second part?
My variable is cat. Is dog.
Very good. Exactly, very close. Awesome job, very good. So you are exactly right. It is my param is cat and my variable is dog. That's what we have here. Just getting those.
On the second one, right?
Say that again.
Shouldn't there be another set of quotes?
Ooh, yeah, you're absolutely right. Brownie points. Yes, I'm missing a pair of quotes there after the plus, or before the plus. I apologize. But there we go. Our output is my param is cat and my variable is dog. So just getting those neurons firing. Everyone feels hopefully back into their old JavaScript days. And now we're going to progress into Java. We're not going that far, everybody. We have our let variable. Let my variable equal dog. This is in JavaScript. When we bring this over to Java, we do something different now. We're doing my variable, the variable name, equal dog still, completely the same, but we're introducing the string. This is how we write a variable in Java. The thing we're doing different is that we're providing this data type here, this string. We're telling Java what exactly this variable is. I'm telling it, Java, hey, my variable is a string, and I'm going to assign it to dog. That's what this line is saying. So why are we doing this? Why is Java making us put string here? Why can't we just keep using let? What is Java thinking? Again, we have our JavaScript. We have our let my variable equal dog. And in Java, we have our string, my variable equal dog. Why can't we just keep them the same? Because JavaScript and Java have a very distinct difference. So let's look at one more example. Let my variable 2 equal 10, and my int, my variable 2 equal 10. On the left-hand side, we can just say let my variable equal 10, and we know it's an integer. On the right-hand side, though, again, in Java, we have to tell what our variables have to be. In this case, I'm saying it's an int, or integer. My variable 2 equals 10. So what is going through the minds of JavaScript and Java? Why are they so different? In Java's head, it's saying, oh, I'll go ahead and assume what type this variable is going to be when you press that run button, when you start running me. I'll figure it all out. Don't you worry. Have a great day. While Java, on the other hand, JavaScript in that case is called dynamically typed. It's figuring out what it wants when you run it. It's kind of trying to read your mind when you press the run button. Java, on the other hand, is saying, hold on a second. You need to tell me what that variable is supposed to be right now. You need to tell me exactly what it's going to be, because I don't want to assume, I don't want to lift a finger. You're going to tell me what it's going to be, because I don't want to figure it out during runtime. This is called statically typed. This is the biggest difference between JavaScript and Java. They're looking at our variables differently. So as we move forward in Java, we need to create data types. We need to tell our variable or our Java application what our variables are going to be using data types. So to this point, any questions? All right, we move forward. Again, Java likes data types. That's why we have to declare our variables in. So it's only natural that we talk a little bit about our data types. We already know one. String, my variable equals dog. Dog is my string. The next one is a char, or a character. My variable, again, equals k. One big difference we see about this is that dog is wrapped in double quotes, while the character is wrapped in single quotes. We need to specifically tell Java that our variable is a string by wrapping it in double quotes, while doing the character in single quotes. If we try to interchange that with single quotes and double quotes, Java's going to blow up. It's going to get very mad, because Java likes rules. Java likes structure. Unlike when we were in JavaScript, where we could use double quotes and single quotes wherever we wanted. The next one is the integer. We've seen this too. My variable equals 10. Integers are those whole numbers, 10, 20, 100, 105, things like that. They're whole numbers. The next one we have is doubles, which holds decimals. It's completely different from integers because integers can't have decimals, only doubles, and the next one we're going to talk about can. So 3.1415 is a double. And then finally, one more is the float. This is our fifth data type. The float can also have decimals. So doubles and floats differ from integers because they can contain decimals, which is very important because we work with a lot of decimals sometimes.
Question.
Yeah, what's up?
So let's say we had a function and we were passing it a number, but we didn't know if it was going to come out as just an integer or maybe a double or a float. How does that work? Do you have to know?
With Java, you do. And luckily, the best part about Java is that there's no question about what it's going to return, because everything in your method already has structure. For example, if you're going to pass in a number, you know what you can only return is a number. We'll go through more examples like that, but because of this structure and this strict rule system that Java has, there's usually no question about what it's going to return. But to answer your question, yes, we have to only have one kind of return type, aka one kind of data structure that our method or function can return. All right.
Question about that, if you don't mind.
Yeah, what's up?
Reading the book, so it described a float as having up to 7 digits, and it describes a double as having 15 to 16 digits.
Yep.
Do doubles need specifically 15 to 16 digits? And if so, is there something in between? Like, I don't know where that gray area is, you know?
Yeah, for sure. So it's not that you have to store 15 digits into it. It's that it's up to the precision of 15 decimal points. If you're on an airplane and you know that the longitude and latitude have to be up to 15 decimals of precision to get us there on time or get us there safely, you want to use a double. That's why floats are only 7 digits. It's there for less accuracy, essentially. So floats have less precision associated with them, and doubles have more precision.
Got it. Okay, thank you.
Absolutely, great question. I see Tay's question here. Can you explain when you should use a char instead of a string? Can there be a string with just one character? I'll answer that second one first. Yes, there can be a string with just one character. I can have the string P. I can also have the string pizza. I can have the character P, but I cannot have the character pizza.
Mm.
Does that help out?
Yeah, but why do you need the char? I think that would be more of my question.
Yeah, absolutely. So chars offer something very, very helpful to us for strings. And we'll explain that here in just a second. But essentially what I'm going to tell you is that strings are made up of chars. Strings with that capital S can't exist without that lowercase c char.
Okay. Thank you.
Yeah, no, yeah, very, very good question too. Coco, can char type be anything as long as they're in single quotes? Yes, literally anything can be a character. Exclamation points, at signs, the A letter, the number 1, anything, but as long as it's in single quotes. So yes, anything can be a character. Look down at your keyboard, all of those are characters. Why is string capitalized? Lisa, fantastic question. String is capitalized for a great thing. So you'll see here that char, int, double, and float are all lowercase. So why are they lowercase but strings uppercase? Well, lowercase indicates something really important to us. It's that lowercase letters like that indicate that these are primitive data types. Primitive means the building blocks of Java, basically like the atoms of Java. It can build everything. While string is capitalized, indicating it's a non-primitive. So what does it mean to be non-primitive? Well, essentially we have our string my dog. A non-primitive with that capital S means that it's made up of other primitives. A string, a non-primitive, is made up of dog with the char D, the char O, and the char G. By the way, char means character. I'm going to use those interchangeably. I apologize. But that is why string has a capital S. Well, everything is lowercase. So fantastic question. And that led me to my other slides. I promise I just had that waiting. So awesome question. Great segue. Kim, can you repeat the double being at 15 to 16 decimal length? Is there ever a time we need more length? Yes, so that is a great question. So the difference between floats and doubles. Doubles can take up to 15 to 16 decimals of precision. I believe it's 16 decimals of precision, while the floats can only do 8. Oh, no, you're right. It's 15 and 7 because I have it on the side. So it's 15 and 16. I completely forgot. But essentially, the double has the storage capacity to create this huge number that we need, while the float has a little bit. So you're asking, will we ever need more storage for the double? That's actually a really good question. Back in the beginning days of YouTube, they actually ran out when, I think it was a Taylor, no, it was the, oh gosh, it was the Gangnam Style video. The Gangnam Style video actually broke YouTube because the view count only went up to a certain amount of numbers. So once it went past that view number, it actually broke YouTube. So to answer your question, yes, there will be times that we need more length. However, doubles are our largest thing that we can store things in. So that's when mathematics comes into play. We actually have to do some creative stuff. So yeah, great question. Unfortunately, I don't have a solution for that. It gets into complicated mathematics, and luckily I don't have to do that right now.
Hey, Kyle.
Yeah, Matt, what's up?
So you got char, which is primitive to string. Doesn't make sense. So chars make up strings, which is, primitive to non-primitive relationship. So does integer have a non-primitive relationship with something?
Not necessarily non-primitive, but a fantastic question. Does integer have something that's a capital I? If anyone's gone through the reading, the answer is yes. We've seen integer with a capital I. We've also seen character with a capital C. We've seen char, my variable equal k, but we've also could have seen character with a capital C, my variable equal k. So we see the capital character and the lowercase character. As always, we know that when it comes to a lowercase c, it's a primitive. Well, capital C in our string context meant that it's a non-primitive. But when we see a capital C on character as well as integer, double, or float, it means something different. This is what we call a box or auto boxing. It's when we create a class around a primitive to help us out a little bit. And what do I mean by that? In this example, we're going to look at the character K. This character K is boxed around it, which means we're creating a character box, that character class that we see that we're using above. It's wrapping the primitive K within it. But why is it doing this? What's the point? It's because now it's in a box, we can put more things on that box, such as helpful methods to help us with characters. Some of these examples is it a letter? Is it numbered? These helper methods are included in that box. So to answer your question, Matt, integer and character doesn't have a non-primitive, but instead it has a class or a box to it. That's what that capital C in character is, and that's what a capital I in integer is. It's that box providing more helpful things to us. Jay, I need more context on that one.
As opposed to, like you got int and integers, does string have a primitive?
Yeah, oh, I see what you're getting at. And I kind of want to put an example in there, like a lowercase string or str. The answer is no. Strings do not have a primitive assigned to them because they are absolutely non-primitives. They are made up of characters in Java. So they are made from building blocks. So it will always be a capital S. Awesome question. All right. And just to show you guys an example of how to use one of these helper methods, at the very bottom, character.isLetter, and we plug in a character there. If this is ran, this would actually technically return a Boolean. It would say false because the number 1 is not a letter. So this is an actual helper method that you can check out in your code. All right. So let's take a quick look real quick. We're just going to tell me the answer here. We're going to look through a couple of these. Tell me what the data type would be. If we had 100, what would that be?
Integer. Integer.
Yeah.
Very good. It'd be an integer. Awesome. How about the letter T?
Yeah.
Sure.
Character. Very good. Char, character. Awesome. 15.90.
Float or a double.
It could be a float or a double. In this one, I have double, but it could also be that float. Capital D or capital F, either one. Awesome. How about pizza?
String.
String. Awesome. And then the final one, the at character.
That's character.
Touche. I said it. Yeah, there you go. Yeah, that'd be a char also. Fantastic. All right. Let's move out of data types for a second and look at another fun classic. Everybody remember classes? Well, these are definitely not going anywhere. I know everyone loves classes. Well, they're back for a second round. Java also has classes in it. But luckily it hasn't changed a bit from what we know. We have JavaScript at the top and the Java version at the bottom. This one has not changed that much. The only thing we do see that's different is this little public thing in the front, which you'll see a lot in Java. So let's take a quick look at that. What does public do? So let's take a look at our example. We have a public class, which is a very common thing you'll see in your code. And then we have a private string myvar variable, which is again to pizza, because I'm kind of hungry. So let's ask a question. Can I create an instance of my class? Can I access my class? Well, the answer is yes, because it's public. You can allow other classes to access your class because it's public. So public means it's open to the public. So I can create this my class thing, but now I need to ask, okay, can I have the value of my var? Can I have that? And it's going to say, no, it's private. That belongs to my class. It's not going anywhere. It stays right there. You cannot access it outside of that class. That's what public and private are doing. Public allows other classes to access stuff, while private hides it away from them.
Is that maybe similar to just like const and let?
Oh.
So let is defining a variable, while const means that variable will only be defined one time. So public and private can actually be attached to those lets and const, or the variable equivalent to let in Java, to allow access or not allow access to those. So it can be used in addition, to answer your question.
Thank you.
But
Absolutely.
how can a public class, if it's public, how can it have private values that they are not accessed? How can you make it public?
Just because I'm out in public doesn't mean I have secrets within me. You can be out in public, but have secrets within you. You don't have to share those secrets, but you can definitely talk to me.
Okay. Thanks.
Absolutely.
I'll take that.
That's what it is that you can create an instance of me. That's completely fine, but I'm going to hold some things into me. But I'm still talking to you, though. I'm not going to tell you about blank. So that's a private thing in my book. So that's kind of how it works, is that you just keep things private, and some things are public.
In the coding world, why would you create a public class and it also contain things that are private?
Exactly. So what if the public class was to charge a credit card, but the private variable would be the credit card number? You want to just be able to charge that card $15, but you don't want that private credit card number to be shown to everybody.
Okay, I'm in. I'm about it.
So there's things that public things can do with private information. So you can run a credit card. You can, I'm trying to think of other things right now. The credit card thing always comes to mind. Social security information, right. If you want to get someone's information, you can have that social security in there to do something else, but you don't make it publicly visible, things along those lines.
Database access passwords. The class needs to be able to use it to get information in or out, and you don't want it publicly accessible to everybody.
Yeah, absolutely. Awesome.
So could the private be public instead within a class? Or is it always private?
So if a class is private, that means everything is going to be private within it. So there's no way to create an instance of me if I'm private. I'm locked away. I'm in quarantine. So there's no way there's no way for other classes to even pretend to access you if you make your class private. That's why majority of classes are going to be public.
And for the private string, my variable pizza, can you make that public string, my variable?
Technically, yes, absolutely. You can make that public. But you'll find as we move forward in Java standards, it's best to keep all of your class variables private.
Okay, thank you.
Absolutely. Very good question. Very good question, everybody. Awesome. Anything else? This is fun. All right. Well, we'll move forward then. Why are we talking about classes? Of course, there are something in Java that are important, and we need to talk about them, but they are more than important. Java is absolutely obsessed with classes and objects to the point where they cannot get away from them. If you didn't like classes in JavaScript, this is bad news for you, is that JavaScript is completely built from the ground up on classes. Anything and everything will always be wrapped in a class in Java. That's one big concept here that we have to know as we move forward in Java, that everything will be a class. So let's give a quick example of that. We have my class, my public class here, and then we have just another one. We have another class that we're creating here. We both make these public so they're accessible. And then we can create a class or an object, an instance of that class within my other class. This is just a small example of how classes will be communicating with each other. You're going to create an instance of other classes within classes, and they're going to talk to each other depending on those accessors, those publics and privates. What does this all mean? Why is Java like this? Because as you've seen in your reading, or you've probably heard, Java is extremely object-oriented. It is built on objects. It likes objects. End of discussion. That's the best thing I can do. It is obsessed. That's the best word I could use. I think there's a better word than obsessed. No, it's just obsessed. Yeah. So that's what it is. AKA object-oriented programming. If anyone asks you what you're doing, you just say object-oriented programming, and then they'll just give you like a blank stare, like, what do you mean? You'd be like, I know what I'm talking about. So try that. All right, moving on. Tell me the truth, yes or no. Quick concepts. Class variables should always be private. True or false?
No.
Wait.
Yes.
False.
It does.
They don't have to be.
No.
I will take that. I'll take that. They technically don't have to be. You can make them public. But the standard, again, in Java is to keep them private. Your class variables, when you create a class, should be private. So it is true, but I will put an asterisk next to it saying that technically you can make them public, but remember, that's not within our standard and it might be dangerous. The next one is private variables can still be accessed within their own class.
True.
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 Very good. It is true. Though you, in your own class, you make a private variable, other methods within that class can definitely still access that variable. Awesome. All classes ever should be written in a single file within the application. Very good. False. I heard a lot of falses. It is definitely false. We should be creating a new class we should be creating classes in its own individual file. That took a lot of brain power to say that. You should have a class in your individual files. I cannot get that out today. One file, one class. There we go. Made it simple. That should always be it for moving forward. So making sure those class variables stay private and those classes stay within their own files. Cool. Let's move forward. Again, we're not moving that far away. Here is our JavaScript. Here's a nice function that we've seen before. So we're going to translate that into Java. This is going to be, in JavaScript, we're going to call them functions. In Java, we call them methods. Though those two terms are synonymous, Java snubs will definitely want you to call them methods. So I will always say methods because I don't want to be snubbed. So if you ever hear me say methods, sometimes I'll mix up too and say functions, but just knowing they are synonymous. So this is what we have. But looking at this method, we're getting some weird. Amber, I'm sorry. I just saw your question. Can public classes only be shared among classes in the same package? No, public classes can be shared amongst all packages. So any package ever, anywhere, can access a public class.
So the thing that threw me, and I don't want to jump ahead too much, but just seeing how when we used that scanner class, we had to have an import statement. But when we were just sharing classes otherwise, that's not something that we needed. And I wasn't sure if that was because scanner was something that was just like baked into the language or.
I would have to see that specifically, that example,
Okay.
to exactly get that. I know there's some little small caveats that you don't have to import packages because of something. I always forget that in Java. But honestly, I always import my packages no matter where they are, just for safety reasons. But yeah, I just say, yeah, public classes can be accessed within any other package within the application, as long as they're in the same application.
So is what we're importing, are we actually importing the package and not just the class, like the single class or the file?
When you imported the scanner, you are importing the scanner's class. Though you do have the ability to import the package, that would be how you would do it. So you can import packages, but I usually recommend importing just classes unless you know you're going to use everything within that package. But you can do both. But what you were doing in that example was importing the class.
Okay, thank you.
Absolutely.
Yeah, and I thought it said that you didn't have to have an import with that.
that there was another way to do it. You just have to type the whole thing out.
Yeah, you could just do utility, my scanner, whatever, wherever it was, like everywhere.
I'm thinking so. No, I'm thinking. Now I'm doubting myself here. I will have to look that up. We will get to that. We will do the scan. We're going to do our scanner example, and we're going to see what's going on because I'm happy to explore that. Okay, yeah, I'm going to write that down. Cool. Okay, so we're looking here at this method. Or I'm sorry, any other questions? Okay. All right, so moving forward, we're looking at our method now. It was translated from Java, or JavaScript, but we are looking at two new things here. We have void, and then we have string in the parameter. So let's take a little bit closer look here. We said we saw void. Void up here, or void anywhere that you see it, means the absence of anything. Or AKA, this method is not going to be returned anything. So that's what this is for. Is it saying that my function that I have up here is not going to return anything? As we said before, Java needs to know if it's going to return anything, no matter if it's nothing. You have to tell it what it's going to return. If it's not going to return anything, that's called void. In another example, if we were going to return a string out of a function, or a method, excuse me, we would say public, then string, because that's what the return type is, then my return method. And then return those quotes, which is a string. These are two examples of how to use return types in our methods moving forward. Marcus, did that explain it, or do you want me to go a little bit more into depth?
Yeah, could you dive in a little bit more with that?
Yeah, for sure. So if I had a method that was just going to print something out to the screen, then that's it, and just return. That Java would be asking, okay, I see you created a new method that's just going to print something out to the screen and then stop. But you still need to tell me what it's going to return. But I would reply back, it's not going to return anything. What are you talking about? Java's like, you got to tell me something. That's when we say void, when our methods will not return anything. Zilch, nada, nothing. It just has return, semicolon. That's returning nothing. That's when we say void. Does that clear it up a little bit, or?
Yeah, I get the concept, but I guess I'm confused as to why would we need a method that's not going to return anything? And I get, when you want to return one, it's going to, you're going to return hello world here, but there's going to be some that don't return anything. But I guess just overall, what's the purpose of something like that? But
right into the question. Yeah, for sure. So into our assignments, we're going to have methods that are just going to take in users' input and print the name out to the console, out to the terminal. That assignment or that method doesn't want us to return anything back. We don't need to return anything. Therefore, we don't need to have a return type. There will be methods out there that don't return anything.
Gotcha. Yeah, that makes sense. I think I was typing when you were saying that part, not like halfway cut out. Okay, that makes sense.
Okay, cool. Yeah, as long as that's it. Awesome.
Kyle, I have a question.
Yeah.
So on your example here, your public void, to me, that method is returning something. So I don't make the connection that that's not going to return anything.
So what do you feel that it's returning?
It's returning the sentence my param is, and then whatever you pass on through as the parameter.
Gotcha. So return, we only return something out of a method if we have the return keyword in front of it. If you look down at this, if you look down at the second example, we use that orange return keyword. That's when we know if a method is actually returning something. System.out.println, it actually doesn't return anything. What it does is that it writes something to our screen. which isn't returning. It's simply kind of doing an action instead. So think of system.out.println as more as an action, but that return keyword is returning something.
I see. I can, okay, all right. I can see that. Thank
Awesome.
you.
Absolutely.
I think that just answered my question that I had just asked.
Okay, cool. All right. So let's move forward here. One more thing that we saw here on this method is that we saw a string. We saw a string up here in these parameters. In Java, again, we need to tell it everything that's happening. We can't leave anything to chance. We told it our return type. We told all of our variables its data type. Now we have to tell it our parameters data type. Everything's got to have a type. That's why we put string here. We need to tell it that my param is a string. That's what I'm going to be passing in forever and so forth. So now whenever I use my function, anywhere in my code, I have to make sure I'm passing in a string. Otherwise, Java will complain to me. So always know your parameter, tell Java the parameter data type. Otherwise, Java will get upset at you. All right, so knowing what we just did, looking at our JavaScript example, remember this is what we just talked about previously. We have our class, we have our my variable that we're defining with let. Remember this is in JavaScript. We have our function, we're putting everything out there. And now we have the knowledge to completely convert this into Java. So that's what we're doing here. This is what our final product would look like if we converted what we wrote in the beginning of class into Java. So that's why I'm saying this is that I'm pointing out the concepts that we have learned in Unit 1 are not going anywhere. They are staying right here. So that's what we're working with. Everything from Unit 1 is just going to be translated over into Unit 2. Of course, there's some different rules that we have to follow, but still those basic knowledge things about coding are still there. So let's finish this up. My method's return type is blank. Therefore, it doesn't return anything. What would this blank be if we were finishing this statement?
Void.
Very good. Void. Awesome. All right, so classes are public and class variables are?
Private.
Fantastic. And then my variable value is going to be a name. So I'm going to make my data type a what?
String.
Fantastic. Everyone get a virtual high five. Fantastic. All right. Woo! Okay, so we have now covered methods, we have covered classes, and we have covered data types, not to mention all the smaller concepts between that stuff. So let's get to the fourth and final big concept we need to talk about in Java. This is the starting point. Every application ever in existence has had a starting point. That's why in Java, we need to define where we want our application to begin. And we have that power in Java that gives us that power. And what we do is that Java needs a main method. Keyword main. We need to define a main method somewhere in one of our classes to tell our Java application, hey, start here. Without this starting point that we see on our screen now, there is no way that our Java application has any idea where to start our program at. This main method is the beginning of the maze, or at the very start of the thread. Anything you want to think about, this is where it all begins. So it's absolutely critical that we have this main method somewhere in our class to start our Java application. This can be included in any of the classes that we want. We just have to make sure it's within the class itself. So one thing that we point out here, well, actually, any questions about that? It sounds like silence, so I'm happy. Or any questions that anyone has about the starting point?
Will it always be public static void main string brackets args?
Very good question. Yes, yes, a million times yes. It will always be in that exact format. Public static void main string block brackets args. And then your code goes inside. This will always be that starting point in Java.
Can you tell me what that argument really means in there?
Absolutely. We have public, so it's accessible. We have this weird word static that we don't really know exactly what it is yet. Void, which you do know what it is. It means the absence of anything returning, so it doesn't have to return anything. The name of our method, which is main. And then it's taking in a parameter with those brackets, which means it's an array. So it's taking in args as an array. So then we place our code there. So that's what it's saying, is that we're creating a method that doesn't return anything that's public, that takes in args. This is where our application starts from. So there's nothing too much to say about it specifically, other than this makes it accessible in the type that it needs for Java to be able to run it. And I know I didn't offer too much clarity on that, and I apologize, but hopefully that offers some kind of help.
I'm just more or less curious of the string bracket args. Like, it's always going to get a, I guess, an array of strings.
I would say don't worry too much about what args means. I would say save yourself from that. But I will tell you that args is passed in when you're starting the application. We won't be using args anytime soon, so don't worry about it too much. But that's kind of just from external, when the application's starting, things can get passed in there that can help out our application.
Gotcha. Thank you.
Yeah, absolutely. And Kim, I see your question, and I believe because those are interchangeable. I'm start to go out. Google that. Well, we'll talk about arrays here in a second. Oh, sorry, go ahead.
I was just a little confused when I was doing the exercises. Even if you use integers, it still takes in string. What? Is there any reason why it's just string, like that doesn't use any other types when most stuff does?
Are you talking about the main method?
Yeah.
So string, it will always be string bracket args. Have you seen it anytime else that it isn't string?
I haven't seen it be string bracket args, but that's what I'm saying. So what if I'm passing it numbers? I'm making something with numbers. It's still string instead of it being int bracket args.
So for the main method, don't worry about args. Do not worry about args here. This is being passed in externally to us. So essentially, don't worry about the main method and what that string bracket args is. It should always be string bracket args, though. It should never be anything different.
Okay.
Yep. We will never be calling to the main method. That is a very good thing to mention, is that we will never call directly to this main method. Never in your code should you call to main parentheses or anything like that, because our application is doing that for us. So don't feel like you have to do that. So the fun part, we see a new word in here that we don't really recognize, unless of course we've already done our reading, but that is the static word. So what is this static word exactly about? What is this thing? And the best way I can describe it is that picture us having a dog class. Again, love dogs. With that dog class, we create 3 new instances of a dog. Remember, classes is like a recipe card. We can make things from it. We're going to make 3 dog objects or 3 dog instances with this dog class. Each of these dog instances, I'm going to give its own values to. They're going to have names and ages. So we have Buddy, we have Frodo, and we have Shiloh. So we have 3 dog instances here. Now, every dog, no matter where you get your dog from, will always be a mammal. Our animal type will always be a mammal, no matter what kind of dog you're creating. Mammal is a value that is shared across all dogs, no matter what you name them, what their age is, they're always going to be a mammal. Therefore, this value isn't unique to any of our instances. Therefore, we can set it as static. This static, what it means is that we don't provide this information into our specific instances, our specific dogs. This information is not accessible directly through a dog object. Instead, we can access this animal type directly through our dog class, not through the instances. Remember, instances are one thing and classes are another. We create instances or objects from classes. The animal type is in a class, while name and age is in our instance. So this means that static variables and methods do not exist in the instance. We can directly access them through the class. So everyone take a breath. What questions do we have about that?
That makes sense.
Make sense?
Yep.
All right, there's a test right now, so get ready in this guy. All right, so we're all okay with instances then? Or instances and static and all that fun stuff? Okay. So let's go ahead real quick and let's put this all together. I know we started a little bit late here, so I'm gonna take it just a little bit more time, but we're gonna just take all what we learned here today and we're gonna put it into IntelliJ. So let's go ahead and meet IntelliJ. Has everyone downloaded IntelliJ? Getting there?
Yep.
All good? Cool. One big thing I want to call out in class right now is that make sure that you have installed the community version. See if I can do it. Make sure that when you start up your IntelliJ, it says community, and it does not say, oh, I forgot what the other one is. Can one of the TAs?
Ultimate.
Thank you, Ultimate. Make sure it does not say Ultimate, because after 30 days of IntelliJ being very nice to you, it's going to ask you for a lot of money. And you don't want to have to do that during one of your assignments or studios. So do make sure that you download the community version. If it's not, uninstall it and just reinstall the community version, and you won't lose any of your work, as long as everything's saved. All right. I think I'm done there. Okay, so I'm just going to create a new project here. So I got a question previously about the JDK and how does that fall into place. So Java is a language, of course. Well, the JDK Java Development Kit is kind of the version of Java that you're currently using. So I'm going to select the 14th JDK to program in. What's different from the 14 from 6? Well, as Java progresses, they include new helpful tools for us to implement in our code. And sometimes if we don't update our JDK enough, we become obsolete, and therefore Java just won't work if we're too far behind on our JDKs. So that's what a JDK does, is that it just provides us with that tool set and Java compiler, all that fun stuff to do our Java application. So we have 14 up there. I click next, next. Oh, and oh my gosh, I am not doing, no one told me. There we go. Okay, I was pointing at this, sorry. Java JDK 14 at the very top. We just want to make sure it says 14 there. Click next, and then I'm just going to type it example project. Alrighty. Can everyone still see my screen?
Yep.
Fantastic. Okay, so I'm in my example project, and here is IntelliJ. On the left-hand side, you will see the project outline of what you're going to be working with. You'll see external libraries, scratches, and consoles. We don't need anything with that. What we do see is example-project. You click in there, and we see an idea folder, and then we see an SRC folder, or source. This is where all of the fun stuff is going to be contained, in that SRC folder. In Java, when we need to create a folder that contains classes, that folder is called a package. In Java, we need to include all of our classes in packages. So we right-click on source, we say new, and we say package. And I'll just say my first package. I've just created a package. Now I'm able to create classes within this. So I right-click and I say new Java class. Let's call it my first class. And there we go. We have created our first class within here in Java. Now, at the very top, we always want to declare our class variables. And then next would be constructors, which we haven't really talked about during this lecture, and then our methods. The thing that we talked about that is very important is our starting point. We need to be able to have a starting point for this Java class. So I'm going to go ahead and just create a quick main method. So public static void main, and then string. I'm going to try this out, Kim, because I'm seeing if it actually is interchangeable. It is interchangeable. That's fun. Okay. So it looks like you can put it over there and over there. Neat. Fun. So they both mean arrays, Kim, to just answer your question. Depending where you put those brackets, I always just put it behind string. I forgot why exactly I was made to do that, but that's what I do. And all I'm going to do here is system.out.println, which is basically how we do console logs in Java. I'm going to say hello world. And I'm going to run this. The first time we run something, we have to click this green arrow. Lisa, if your IntelliJ looks nothing like that, make sure if it's all black, you might be in dark mode. But if it's completely different, then you might have that ultimate version. So there we go. Oh, sorry, go ahead, Lisa.
The community version, but it's in the dark mode or whatever because it's got the black screen. But like when you first opened up and got all those choices in the beginning, I don't get that. I have to kind of poke around up at the top to find all of that.
Oh, to find the project on the left-hand side?
Yeah, the stuff that you had before you opened up to where you are now, when it was just the stuff in the middle of the screen that gave you the different choices. I never have seen that.
Are we talking about this screen right here?
Yeah, I
one,
never
one
go
after
there.
that, yeah.
Oh, okay. If you,
It might just be a different version.
It might be a different version.
Like a newer version.
Okay, it might be a newer version. Also, if you already have a project, or yeah, it might just be a new version. That's just the welcome window. Honestly, as long as you can open up the project into a screen like this, though, that should be a-okay. If you do have more issues with that screen, definitely talk to your TA or reach out to me. We can figure something out.
Thank you.
Yeah, absolutely. Okay, so we have officially created our main method. We have done hello world. So let's go ahead and do a class variable. As you can see, I put my static method at the top just because I like to know where it is. So I put it at the top of my classes. Then I usually do my class variables, then the constructor, and then the methods. So we said we just do private string. Again, we have to do our data type. Actually, when we're creating that variable, we say my variable. There we go. And then I'm not going to do anything in the constructor. And then just do a public void. What is my variable? In there. Now, a big thing here is that make sure that your methods are lowercase in the very front. That is a Java standard. It's the same thing in JavaScript, so I wouldn't say anybody different, but just making sure that your first letter in your method is always lowercase. And then what I'm going to do is that I'm going to system.out.println, and I'm going to say this.myVariable. Remember, what this does is calls to our class variables or our class methods, which is my variable. That's why I can put this here in our system.out.println. It could also look different for PC, Crystal, that's for sure. Let me get my PC back up and look at it. Okay, so if we run this, what we are seeing still is hello world. Because again, this is our starting point. We haven't told it at all to run what is my variable method. So how can we do that? Well, we're in a static method here. So that means this class instance is not available to us. So because it's not available to us, we have to create a new instance of my first class before we can call to methods outside of it. So that's what I'm going to do now. And how we create a new instance of that is my first class, Yeah, that might just be the PC one. I'm looking at lecture questions right now. New my first class.
Class is misspelled, the first one. Yeah,
you.
there you go.
Thank you very much. I'll say my first class dot, what is my variable? And I'm going to comment out hello world. I'm going to run it. And now I'm getting back pizza, the word of the lecture. So up until this point, any questions about how we're accessing these methods, how we're creating the main methods, or even creating our first class here in Java and or IntelliJ? All right. Well, then the final thing I want to introduce to you all is the last data structure we have. Oh, real quick, we're going to do a quick recap one more time. What contains all of our classes forever and always? What contains all of our classes in Java?
The package?
The package, very good. The package always contains all of our classes. All right, what method is needed to start our application?
Main.
The main. Awesome. And then finally, what primitive are strings made up of?
Char.
Chars. Fantastic. Great job, everybody. All right, last things last. Arrays. This is the last data structure I wanted to go over with you all before I turn you over to your individual groups. So arrays are not going anywhere. They're our favorite data structure, right? They are those containers that we can just place things in. But in JavaScript, we could contain anything we wanted within our arrays with no backlash. But unfortunately, that's not the case here with Java. When we are creating an array here in Java, we need to always, again, provide our data type. That's why we put string, open and close square brackets, my array equals square brackets, some strings. Those are our dog names. Those are our dogs' names. When we actually look at that kind of more in a true 2D sense on our screen, we see that it's an array of 3 different compartments, 0, 1, and 2. And then we place those strings within them. That's what this array looks like. Another way we can create a string, another way we can create an array was we do that string, open and close square bracket, my array equals new string, open bracket, however big we want our array to be, and close bracket. This is how we create that array. We want to assign it. It's just very similar to JavaScript. We plug in the index we want to reassign, and we say equal to whatever string we want to put in there. We can build arrays of strings, of characters, of integers, doubles, floats. It doesn't matter. We can build an array of anything. We just have to let Java know what it's going to be.
If we're declaring an empty array, do we need to have that number in the brackets to say how many items will be inside of it?
Absolutely, yes. So the first example you hear is saying that we know it's going to be in the array. The second example is saying we don't know what's going to be in the array, but we always do have to provide how large it's going to be. So you're absolutely right. We do have to always provide that number.
So can we ever add items to an array, or is that aspect of it immutable?
That is absolutely immutable. Once an array is set, we cannot change it. If I create this string of 3, array of string of 3, I can't make it 4 or 2 anytime soon.
Okay.
Very good question. Any other questions about arrays?
Then if you want to, So then if you want to add to the array, you have to create a new array? Or do you just not do that as much in Java?
If you wanted to resize the array?
Yeah. So if you want to add something onto that array, does it just create a new one?
Yeah, so if I wanted to say add like a new dog name to my example that we're looking at now, I would have to create a new array of string bracket 4, and I'd have to basically do a for loop to loop through it and add all my other dog names in there and then my new dog name. So it's definitely a headache to resize arrays for sure, but it is possible. but we'd have to create a new array to do so. Awesome question.
So, say for some reason you wanted to make an array of more than one data type, can you do that?
Unfortunately, no. We have to tell Java what's going to be in all of our indexes of our arrays. So they have to stay consistent. So all of these indexes will be strings. We can't have strings and integers within one array. Everything has to be of the same exact data type.
What if we don't know yet how many objects are going to be in the string? Or I'm sorry, how, like in the second example, we have 3, values in the array. What if we don't know? Like you can't, because in Java, you can't initialize an empty array and then push to it. So what do you do if you don't know ahead of time?
For arrays, you make your best guess. You finger cross and you run a Hail Mary, basically. You're really just hoping that you know how much you need for that array. But again, that's just arrays. Foreshadowing, there are data structures out there that allow us to resize storage devices to what we need by pushing and popping. So don't think arrays are the end all be all. We have more things coming down the line here that will help you out with those kinds of situations. So hopefully that helps. All right, any final questions? Because everybody, we are finished here. So I am, let's see, one more person typing. So any final questions I can answer for all of you all before I turn you over to your breakout rooms. Breakout groups, excuse me. Okay, well, in that case, guys, thank you very, very much for sticking with through with me on my first class. I hope you did enjoy it. I really, really do enjoy doing this. I'm excited to teach you all. From the questions I got today and from all the answers you've been giving me, I am super excited to see all of you move forward with Unit 2. You're doing already a great job. So awesome questions today, awesome participation. Thank you again for all these questions. If you ever need anything answered specifically, feel free to message me directly or just post in the lectures questions as well. So thank you again, everybody. I think I'm done here, unless Greg, you have anything at the very end of class. I am all good.
Thanks, Kyle.
All right, thanks everybody.
Nice to meet you.
Good night.
Thank you.
Thank you, Kyle.
Thank you.
Good job, buddy.
Thank you.
Thanks everybody.